Hi everyone, so welcome to my channel. So this is going to be a day one for Gate 2023, and the subject is gonna be electronic devices, right? I'm going to share with you the roadmap for electronic devices, how I'm going to proceed, for these subjects. Subject is very important as far as the semiconductor is concerned, and as far as the Gate 2 is concerned. Each year you will find around 10 to 12 marks question from, right? So, so the day one, this is going to be a day one, right? Day one is strategy, right? And I'm gonna share with you the roadmap for electronic devices to prepare, right? So many students have been requesting to me on different social media platform that they are not getting good content on electronic devices, right, for gate examination, and they fail to answer the question. In fact, I have seen also many people they make mistake, they give very big answers related to electronic devices and circuit, right? So first of all, uh, okay, let me check whether voice and everything is okay. Yes, everything is fine, right? So the day one is going to be on the introduction to electronic devices, and what are the topic I'm going to cover, right? So the I'm going to cover each topic. So I can say I'm going to dedicate 5 days in a week, right? So in week one, what I'm supposed to cover, right? So the week one, so in 5 days I'm gonna cover. Okay, so in the week one, what are the topic I'm gonna cover? So this electronic device is gonna be for PC student, right? For electronics and communications, so they would be able to score around 10 to 12 marks, right? 10 to 12 marks in the gate examination, as well as they would be able to clear, the various interviews, once they get good rank in gate examination, they are subjected to appear in the interview, right? So many questions are asked, right? Okay, the very first topic which I will be talking in electronic devices will be the introduction to semiconductor. So my question will be, why semiconductor? Why only semiconductor? Why not insulator, metal, and other material which are available on the earth, right? So the introduction to semiconductor. So I'm gonna talk about introduction to semiconductor. Semiconductor is one of the very good material, okay, and in order to understand semiconductor and semiconductor physics, okay, so introduction to semiconductor. So we will divide electronic devices into two parts basically, right? So we will discuss first what is semiconductor, why semiconductor is so important, right? So based on our first introduction to semiconductor, it will help us to decide. Okay, so I'm going to divide electronic devices into two house. Okay, the first house is going to be the physics, semiconductor physics, or you can say device physics, right? Or you can say device physics. We are going to talk about only device physics here, right? And once the device physics is covered, okay, you would be able to, start building the devices. Okay, so here we'll talk about various kind of devices. Okay, so under devices, what we will cover here is we'll talk about various kind of devices such as PN junction, right? One of the fundamental. Okay, then we will talk about once the concept of PN junction will be clear, we will talk about bipolar junction transistor, right? Okay, and then we will talk about once the bipolar junction transistor is covered, okay, we'll talk about MOS capacitor, right? Okay, to understand MOSFET. So if you want to understand MOSFET, right, the MOS capacitor is one of the very important concept, okay? And in order to understand bipolar junction transistor, you need to know what is how PN junction works and how PN junction comes into, right? So, and also we'll talk about various things, various kind of devices, electronic devices. But before that, we need to build the foundation to understand devices, okay? Unless or until you know the semiconductor physics, okay? there are many paradoxes. Okay, there are a lot of confusion among the aspirant who are preparing for gate examination. They easily end up solving questions from network controls, signal and system, digital circuits. Okay, but they fail to solve questions from electronic devices. So that's why their rank goes below, and they go out of the league of the topper, right? Okay, so let me check the comment as well. Um, okay, if anyone is live here. Okay, so it is day zero, you can say, or day 01, right? And so the introduction to semiconductors. So I'm going to answer you, okay, why semiconductor is important, right? So this is just a roadmap I'm covering for electronic devices, roadmap for gate 202, right? So the question will be why semiconductors. So semiconductor physics is very, very important here, right? The semiconductor physics is going to be very, very important, right? Conductor. So my question is going to be why semiconductor? Why semiconductor? In fact, nowadays questions are being asked from MOS capacitor and MOSFET. Okay, so the question will be why semiconductor, right? So before that, in fact, I would like to introduce one more concept, right? So in order to understand electronic devices, okay, we'll talk about why semiconductor. Okay, keep thinking about it. Why semiconductor? Why not insulator and conductor and other material, right? So we'll discuss about in to understand entire electronic devices. Okay, we will take the help of energy band diagrams, right? Energy band diagrams, band diagram. If you don't know how to draw these diagrams, you cannot understand any device physics. Okay, you cannot understand in general. Okay, somebody claims that they are able to talk about electronic devices and they don't know how to draw and how to make quantitative and qualitative conclusion out of energy band diagram. They do not understand the electronic devices. In fact, one of the uh, Nobel laureate also says that if you don't know the semiconductor energy band diagram, right, how to draw energy band diagram, you cannot understand the semiconductor physics, right? So please keep this in mind. Right. So one of the Nobel laureate also says that if you don't know how to draw the energy band diagram, you cannot understand or explain devices or semiconductor based devices. Semiconductor, what is the need of and why semiconductor is you might have read or studied about semiconductor devices, right, already. But I'm going to make entire subject a little mathematics as well. I will talk about different mathematics, devices, how to derive those formulas. But before that, we will discuss about energy band diagram. Okay, for each devices, how to draw the energy band diagram. What is the need of semi? Why semi? That is my keep thinking. Okay, keep. I will be answering questions next because this belongs to the roadmap only. What content I'm gonna. This question will be answered in the next season. So let me go to the next page and talk about our content, our roadmap. Right. We week one is gonna be uh, the introduction. And next topic will be here. We'll talk about introduction to bands, introduction to bands, and many questions. Right? How bands are formed and from where those bands come. When you look at any textbook, right, you some block, induction band, balance band, but you don't know what's happening behind those blocks, right? How those, how those, from where those blocks are coming, where these energy bands are coming. Okay, so you understand energy band diagram as well, right? Energy bands, introduction to energy bands. I'm gonna talk where we will discuss the very important parameter that will gap. So we'll get this, and it is denoted by easy, right? So these things I'm gonna cover in week one only. I will be covering all. Third topic which I will be covering here is the fundamental of band structure, fundamental of band, fundamental of band structure, right? So under this topic, I'm gonna talk about how EK diagram comes, how EK diagram comes, how semiconductors are classified as direct and indirect band gap of semiconductors. And many times you will find that a direct band gap of direct band gap, right? So which parameter is going to capture the information related to band structure? That I'm gonna talk. So under fundamental of band structure, I will be covering many concepts. In fact, I will talk about effective mass, so how electron inside the same crystal, right? How does mass vary if electron moving outside the crystal or moving freely, right? So that mass will be uh, it will not be known as effective mass. That will be the normal mass. But if the electron inside the crystal, that mass becomes effective mass. I will be talking about of effect, the help of EK diagram. How EK diagram is drawn, all these things I'm gonna talk in the. So EK diagram is gonna. And next, fourth topic is fourth topic. What fourth topic will be the Fermi Dirac distribution. What is the need of Fermi Dirac distribution? What is the need of Fermi Dirac distribution? Dirac distribution tell us, okay, it will tell us the probability of charge carrier, probability of electrons whether they are present, okay, above certain level or not. Just a statistics, okay. Finding probability, okay, finding probability. So here we will talk about Fermi level. Here we will talk about level and by introduce fact the energy band diagram. After this band, for, after this band structure, band structure, and then we'll talk about density. What we will do here is based on the density of state, with the help of density of state and with the help of this Fermi Dirac distribution, we'll combine them that it will give us exact number of exact number of electrons or exact number of hole in the valence band, exact number of hole in the conduction, okay, or inside any conductor. Fermi Dirac distribution only tell us the probability that you can find the number of electrons with the help of only Fermi-Dirac statistics not be able. But if you combine Fermi-Dirac distribution plus the density of combining the two, you got the help of Fermi-Dirac and loss density of find what concentration of electron and the and then this is going to be our week one. Week one is 5 days, 5 days are the roadmap. The introduction to without talking about not get started electronic before understanding the electronic devices have great fun build introduction introduction to bands. There are many questions are there how bands are coming, how bands are and the energy gap that is the depending upon gap we classify okay fundamental of band structure talk about EK diagram how EK diagram then we'll talk about Fermi Dirac distribution. My plan for week one is okay and the week two is what week two talk about doping and intrinsic array concept topic I will talk why we need and we'll talk about intrinsic array concept say that what we are going to do here is we'll classify the same based on purity okay and based on the we'll talk about intrinsic concept of doping okay and then we'll go for talk about why we need why we do doping exactly into and then we'll talk about equilibrium carry concept what is the of carry concept and week three I mean in week two we are going to take third topic as the temperature dependence of carry concept is what fact what kind of effect will be there for carrier constant temperature dependence and then we'll talk about the fourth topic is high doping effects and ionization high doping high doping so with the help of energy band diagram I'm going to you will dope the same very high so how your energy band diagram look like okay because in the interview they always ask questions they will give you some high doped semiconductor and they will ask you to draw the energy band diagram this is my plan only four topic I will be covering and one numerical system for each. Around numerical system, I'm going to cover 20 very good questions for GATE exam. Numerical system will be covered the rest day of the week. And here also I will cover one numerical system, 20 questions, again 20. Very good. Week 3, you're going to, right, you will not be able. Please make sure that you have already taken classes. The week 3 is gonna be the very first topic I'll be covering, talking about the carrier scattering, and ability. So, what is how mobility carrier is scattering? Also, this difference between scattering and recombination. We'll talk about different kind of scattering, lattice scattering, Doty scattering, and many more. And then we'll talk about low field and high field under the effect of electric field. How uh, we are going to apply low field across the same, how electron, all those things. Low electric field means by the high, how electrons and that is what. Next one we will talk about the third, or you can say the talk about introduction to how, when can diffusion happen, right? What is the case where the diffusion is happening? What kind of that how semiconductor is doped, where can happen? All those semiconductor is non-uniform, right? Suppose this is just semi. So till now I did not answer about why semi, but remember that suppose this is a semi, right? And here semiconductor is doped heavily, and then gradually, here the semi, I mean, don't, but okay, so here the concentration more and diffusion will happen. Diffusion will happen from high concentration to low concentration. That is the process of also transport. Okay, natural process. Don't need fact to apply any kind. Then we will talk about our third topic that we drift. Ready? How drift occurs, how diffuse. That we will discuss on very important called Einstein, and we will derive by that formula. Okay, the help of see the magic of energy band diagram. How energy band diagram help you recall the formula and everything. 1 inch long formula you would, and then we'll talk about that. Talk about topic that trap statistics. Trap trap is very important. Questions are being asked from And the next topic will be here, continue fifth topic, current. So this is my plan for week 3. My plan for that for the other topic, carrier scattering. The week 4 will be how we are going to of this. We are going to week 3 going to attend my classes for these master. I can then yourself able to explain how PN here and what is the energy band diagram for what are the parameters PN junction. Okay, how to determine anything, any concept, right? So we'll discuss about that. So remember that energy band diagram EBD is one of the tool. Okay, okay. So using EBD energy band diagram, we can do quantitative analysis. Quantitative analysis. We can in fact find some values, okay, related to any devices, okay, and we can also do qualitative analysis as well, right? So remember that do attend these week 1, week 2. So once we'll complete this, I'm going to share for the further weeks, for PN junction, for bipolar junction transistor. So why semiconductor, right? With this, I'm going to end this. Why semiconductor? Okay, let's meet the next class. Why semiconductor? Very, very important. So I'm gonna cover all the practical real life example. I'm going to correlate practical real life example with semi everything, right? So that will make the class interesting. Please follow this, and you will not lose any topic. Okay. So please do watch this session, like, subscribe, share, and understand. Okay, the real concept. I hope this session will give you some insight related to electronic devices. Thank you so much.